Alright, this is my video for the final scene in the GAM 370 final project. So starting out looking at the pre-made models, or actually in the model header we can look at the new standard vertex that includes the vector for the normals as well as a mesh num to keep track of any models that have more than one mesh. Down here in our pre-made models we have the unit box repeated texture, the pyramid, the sphere, and the skybox, which we'll be using in the final scene. And then in the actual CPP, we have just a model function to create based off an array of standard vertex and triangle by index arrays. We have a function to create model given a file that will load from data, and then we have the pre-made models here where we can call the create inside of our model tools. But if we take a look in model tools, you have just the regular unit box. We have the skybox, which is essentially the unit texture repeating box, except we will have all the faces facing inwards. And then coming down we have the actual unit box repeating texture, now updated to set the normals of all the vertices, which happens after each square is created. And then we have the unit pyramid, just creating the 4 triangles and then the 2 on the bottom, and we set the normals here after we create the vertices, or while we create the vertices. We have the unit sphere. Normals weren't quite working, and then there's an issue here in setting the UVs that gets a weird kind of hexagonal pattern, but that'll see that in the scene. But if we go and take a look at the terrain class, which had the function to create the terrain, takes in the height map and the various user-defined variables, and then we have just a pointer to the model and a world matrix. We have just the render as well, just to call that. I have a get model just for the sake of the terrain and the skybox. Couldn't get their classes set up independently, so for ease of use I just wrapped them inside of the graphic objects to clean it up a little bit. But in the terrain model we just get the height map from the image, and then down here we set the vertices with the X position, and then the Y based on the height value, and then we set the Z as well as our U and V's. We set the normal here inside of our vertices, and then we just set our list of triangles down here, and again just the render, and then some functions that didn't get used. And looking at the new updated shaders, we have in the HLSL we have the color light, which now has the material and the fog for the lighting. And then in the color light we have a fog data buffer that stores our fog values. And then down here at the bottom we can use those values defined by the user to determine our fog percent, which is applied to the lit color, which we can see down here that's inside the shader color light, where we have our fog data struct with the buffer. Should be then create in here the size of fog data, setting that context, and then we'll call it to set default values so that we're not creating fog if the user has not defined for fog. And then we just have a send fog data function to set those fog values inside this buffer. We also have the texture light with the same material and fog. Try to get fog data working with that, but there were some issues getting the HLSL to compile, so that didn't work out. but down here we just have the same lit color computing with the light. And in the shader texture light we have here, just be able to set directional point spotlights. I had some framework for sending the fog data, but had issues with the HLSL, but it has essentially the same setup with the buffer and the struct values. And then we have shader texture. This is, oh, not shader texture. Looking at the graphics objects. That's what I'm looking for. Just have the graphic object base, which is just some undefined functions that we'll use. The render is just an abstract to override, and then we have a set model that we'll use when creating the new graphics objects, and then just a model that they can all share. In the graphic object color, just have the set color and set world function, and then our shader color and our color. Just pretty simple functions in here for setting the color and the world. And then all of our constructors, we're just setting the model and our shader to what was given to us, and then we'll initialize to some default values. And in the render, we're just setting the world and color and calling the render. Then we have the graphic object texture. Similar stuff, except now we're dealing with textures instead of colors. We have pointers, since this will be an array of textures, since we're dealing with multiple meshes in a model. Yes, we have the set texture with just one texture given, which will set the texture for the entire model, and then we have a set texture with a given int that will set a particular mesh's texture. So if we look in this, we can see that when we're constructing, we're doing the same thing, calling set model and saving the shader, and then we get the mesh count from our model, and then we'll run through just nulling out the textures to start with, and then we'll do the same thing inside of just a set texture, running through all the meshes, setting the texture, and then in set texture we'll set the given mesh to the texture that was given, and in the render just taking care of some data at the top, and then we're basically running the same process of sending data and setting all of these textures to context for each mesh, and in the model we're calling the render mesh function. Which, if you look in here, we have just the regular render as well as a render mesh, which allows us to render individual meshes of the model. And then we have the graphic object texture light, which is essentially going to be the exact same thing, except now we're also dealing with arrays of ambients, diffuses, and speculars for each of the meshes as well. So pretty much looking at the same thing in here, just a couple more arrays that we're setting to default values, and then we can call set material here. And then the render is about the same, except we're going to have to also send the ambient diffuses and speculars to the shader, and then we can call render on that mesh. We could take a look in the actual DX app. Looking in here, we have a couple matrices that are used for storing some transform values that are manipulated or used a couple times. We have all our models here with the plane as well as the terrain model, all the texture pointers, and then all the graphic objects and all of the shaders. If we look in the application, looking at our deconstructor, we can just see all the shaders, textures, models, and graphics objects are being cleaned up. And then down in our init demo, you can see we're just creating our shaders, our textures, which we're getting from our textures folder here with the TGAs. We have our models. We have a couple pre-made models that we're loading, as well as some models that we're grabbing from the files. And then down here we have the terrain model, which we're grabbing from this height map with some set values with the repeats of 10, just so it's a little bit bigger on the textures. Setting some matrices, and then down here we have the graphics objects, where we have the graphics object color, which is just a box that's yellow that represents a light that's moving around. And then we have some graphics object texture, which is just the skybox with the sky texture. One more color that's just the sphere that's blue, that isn't taking any light since it's not a color light. And then we have all of our graphics object texture lights down here, which we just have a frigate. This is the terrain, just grabbing the model, wrapping it in a graphics object so that it's easier to use. We have a cottage here that has multiple meshes that we're setting here for 0, 1, and 2, and then just updating the world. Then we have a couple pyramids that are in the scene, all using the pyramid texture. We have another multi-mesh object that has 2 this time, setting 0 and 1, and then setting that position. And then one more period, and then or pyramid, and then another box. And then up here in the update scene, we just have a pyramid that is spinning, which is happening right here, and just resetting that world. These values are changed a little bit, you'll see, just because the FPS is a little bit lower, so the update isn't happening as much, so the values are a little bit bigger to make up for that. And then down here we're just setting the shaders to context and then calling render on the graphics objects using those shaders. And then down here we're setting our lights, and then we set our shader texture light to context, so then we can render all of the graphics objects that are using the shader texture. If we run this, any day. Alright, so you see the frigate loaded here with the light spinning around it. We'll see that spotlight lighting it up. And then there's a directional light in the scene coming from the top. We have the terrain here with a ground texture on it. This is just the box, just to have this in the scene. You can see when the spotlight comes around, you'll see the pyramid and the box light up, as well as the terrain. It's a little hard to see. We have another tree model that's being loaded from the file here, with the light spinning around, and then we have the cottage with the meshes being set to different textures. And we have the other file with just 2 meshes, each one being set differently. And then we just have a couple more pyramids scattered throughout. This is the skybox. And then we have the unit sphere with the blue color. But the UVs are right when they're starting out, but something gets messed up that I couldn't fix. We get this weird kind of I don't remember what that's called, but it's a little weird diced pattern. Houndstooth, that's what that's called. That's not relevant though. But that is the final scene.